So, as you said, we'll do complex number today, okay? So, so in your class 9 and 10, you might have done number system, okay? So, in number system, it starts with natural number, okay? So, whatever number you are counting, those are called natural numbers, starting from 1 to n, 1, 2, 3, 4. So, these are called natural numbers. Whatever you are counting, starting from 1 to 1, 2, 3, 4, those are natural numbers, okay? And then comes the integers, okay? So, like say 1 minus 1, 2 minus 2. So, these are integers, including 0. These are all integers. So, natural numbers are a subset of integers, right? Then, so we'll do today complex number. Before that, I am just introducing you to the number system, okay? So, complex number. Okay, so if we do complex number, we know that we have natural number which is a subset of integers. Okay. So natural number 1, 2, 3 like that. Right? Then integers. Your integers are kind of minus 1, minus 2, minus 1, 1, 2. So these are all integers. Okay. Then these integers are again a subset of real numbers. Okay. So real numbers means all fractions are included there. Okay. So real numbers, it includes fractions. So the subset is symbol is this. Okay, subset. Okay, so this is subset, and this opposite of it is called superset. Right? So so real number, it includes fractions also. Includes fraction. So these are the things you might have done in your class 9 and 10. Then we will go to complex number. Okay. So what is a complex number? Okay. A number in the form of a number z in the form of x plus iy, where x and y are real number, and so let us say a number, let us say this is z, okay? So if we write it as x plus iy, okay, where x and y are real numbers, okay, real numbers, but I is equal to square root of minus 1. Okay. So we know we can find out a square root of a positive number, but we cannot find out a square root of a negative number. That's why this concept of complex numbers comes there. Okay. So this I is equal to minus 1, and then this number z is called a complex number. Number z is called a complex number. So this part, so in this complex number, x is called the real part of the complex number. Y is called the imaginary part of the complex number. Part of complex number. So a complex number z is called purely real if y is equal to 0. Okay. So z is purely real if if y is equal to 0. If
Yeah.
y is 0, it is purely real. Z is purely imaginary.
If x is equal to 0.
Purely imaginary if x is equal to 0. Correct? And how do we represent a complex number? Okay, so we represent a complex number like this. We'll have two axes. One axis we'll call as real axis, another axis we'll call as imaginary axis, and that diagram is Argand diagram. Okay, so let us say I have two axes. Okay, so this axis is my real axis. This axis is my imaginary axis. Okay. So these are my two axes. So if I want to, if I have a coordinate, let us say P. Okay. So this coordinate will have a x coordinate. So this is your x coordinate and this is your y coordinate. Okay. So this is your y coordinate. And this is the point P having coordinate x and y. And here we can say x is a real part of z, y is imaginary part of z. Okay, Im or Re. So
Yeah.
So in Argand diagram, your x-axis is real axis, your y-axis is imaginary axis, okay, and you represent it like this, okay. Then integral power of iota. This I is otherwise called as iota. Okay, so this I is iota. Okay. Okay, so then some MCQs can be on integral power of iota. Integral power of iota I. Okay, this is integral power of iota I. This is very important. So you know I is equal to square root of minus 1.
Yeah.
Okay, then I square is equal to minus 1, right?
Yeah.
I square is equal to minus 1. Then I fourth, what will be I 4? I 4 is equal to minus 1 into minus 1, which is plus 1. Right?
Yeah.
So I 4 is plus 1. So if n is an integer, okay, if n is an integer, if n is an integer, so or I to the power 4n is always equal to 1, right?
Multiple of.
So this is I to the power 4n. If n is an integer, I to the power 4n is always equal to 1. So like I said, I to the power 4 is nothing but I square into I square. So which is nothing but minus 1 into minus 1, which is equal to 1. Right? So this is my I4. So whether it is plus 2 or minus 2 doesn't matter. So let's say I to the power minus 4. What it will be? It will be 1 by I to the power 4.
Yeah.
So you know 1 by I to the power 4 is nothing but 1 by 1. So
it's 1.
So whether it is a if it is an integer, if n is an integer, I to the power 4n is always equal to 1.
Yeah.
So if it is 1, then I to the power 4n plus 1 is in nothing but I to the power 4n into I to the power 1, which this is 1, so that means it is I, right? So I to the power 4n is equal to I. 4n plus 1 is equal to I.
Yeah.
Then I to the power 4n plus 2 is equal to minus 1.
Understood.
Okay. So I to the power 4n plus 2 is nothing but I to the power 4n into I to the power 2. So I to the power 4n is always equal to 1. So I square is equal to minus 1. So this is minus 1.
Minus 1.
Okay, so there can be short questions on this. Okay. They might have given say I to the power 257 or something. So
You have to
divide
split it in according to
yeah.
multiple of 4.
Divide it by 4, multiple of 4, and then after 4, how much extra is there?
Yeah.
Let me say I to the power 100. Okay. So I know it is I to the power 4 into 25. So it is nothing but it is 4.
A multiple of 4.
It's
Which
a
is
multiple
1.
of 4, that's why it is 1. Okay. But if I to the power 101 means I know it will be I to the power 100 into I to the power 1, right?
Yeah.
So I to the power 100 is 1
Into I.
into I. So there can be questions, simple questions like this. Okay. So the complex number z is equal to x plus y, iy can be represented by a point P in a plane called Argand plane. Okay, so this plane, the complex number can be represented in a plane called Argand plane. Okay, Argand plane. So a complex number can be represented in a Argand plane, or it is otherwise called as a Gaussian plane or complex plane. Okay.
Yeah.
So the coordinates of P are referred to rectangular axis xo x dash yo y dash, which are called real and imaginary axis. So this one, what I have written, like say x o x dash, okay, and then this is y, this is y, this is y, this is y, this is y dash. So your x o x dash is your real axis.
Yeah.
And y o y dash is your
Imaginary axis.
Clear?
Yeah, understood.
Okay. You can take a snapshot of this. So now, how do we represent a complex number in Argand plane or Gaussian plane or complex plane that we have represented? So in a Argand plane or a complex plane or in a Gaussian plane, you have a real axis, you have an imaginary axis. So this concept of imaginary number, complex number comes from that square root of negative number. How do we represent the square root of a negative number? So that's why the introduction of complex number. Okay. So in number system we have natural number, we have integer, we have real number, and then we have complex number.
Yeah.
Okay. Then algebra and equality of complex number. Okay. So some algebra and equality. Okay. Algebra and equality of complex number. Complex number. Okay, how do we add complex number? Okay, let us say my complex number z1 is equal to x1. My complex number z1 is equal to x1 plus I y1. My complex number z2 is equal to x2 plus I y2. Right?
Yeah.
So if these two are my complex number, then what is my z1 plus 2 z2? How do I add? I just add the real part
And then the imaginary.
and then the imaginary part. Okay, So this is the addition. Okay. How do we add two complex numbers? Okay. Then what is the subtraction? These are very easy things. Okay. Z1 minus Z2 is equal to x1 minus x2 plus I into y1 minus y2. Right? That is subtraction. Then how do I multiply? Okay. Z1 into Z2. What is the result of multiplication? So it is x2 y2 minus x1 y1 plus I into x2 y2 plus x1 y1. I into x2 y2 plus x1 y1. So how do we get it? You can derive it. How we have it. So you just remember this. We can easily derive it actually. So you just remember that in the real part you will have a minus sign. In the imaginary part you have a positive sign. And it is x2 y2 x1 y1. That's all you have. You are not like x1 y2 x2 y1. Not like that. Same thing. We just have to remember this. You can derive it, but it will take time. Okay. Then this is multiplication, then division. Okay. Z1 by Z2. Okay. So this division again the same thing, like it will be this one will come this side, x2 y2 plus x1 y1
part by real part
plus I into x2 y2 minus x1 y1 divided by x2 square plus y2 square. This one.
Okay.
Just remember this one, x2 square plus y2. x2 square plus y2 square.
Second numbers.
Second number. So this is my division. Only difference is in the multiplication, whatever is coming with I, this will be
the reverse of that.
So that is my Z1 by Z2. So there can be MCQ. So you just have to remember these things. So when you say Z1 and Z2 are equal, so Z1 is equal to Z2
if real and imaginary parts are
if the real and imaginary, x1 is equal to x2 and
y1 is equal to y2.
If this condition is satisfied,
that
then two complex numbers are equal. Okay, so another important thing is complex number does not possess any inequality. Okay, so complex number does not possess any inequality. Why? Because let us say you have 3 plus 2i. Okay. Let us say I have a complex number. This is my 3 and this is my 2. And let us say this is the real axis. So in real axis it is 3, in imaginary it is 2. So this point is 3 plus 2i, right?
Yeah.
So another imaginary number is, let us say, 1 plus 2i. Okay, so I have a number. So let us say this is 1 and this is 2. Okay? Let us say this is 1 and this is 2. This is 1, this is 2. So it is 1 plus 2i. So we really cannot compare these two things.
Yeah.
So there is no meaning of inequality in complex number.
Understood.
Okay. Then there is something called conjugate of complex number and modulus of a complex number. So this is called conjugate and modulus. What is conjugate of a complex number? Conjugate of a complex number. What is conjugate? So if z is equal to x plus iy, its conjugate z bar is equal to x minus iy. That's all. That is my conjugate. Okay. And then what is the modulus or magnitude of a complex number? So if this is z, z is equal to x plus iy, then my modulus or magnitude z bar is equal to x square plus y square.
Square.
So these are, one is modulus, one is conjugate. Okay, so then you can take a snapshot of it. So these multiplication and division you have to by heart. No, we cannot derive. You have to by heart those things. There are certain formulas we have to remember. There is no other go, because you are doing objective questions, not subjective questions. You have enough time to derive things. Okay. So, what is conjugate and what is modulus of a complex number, that we have told. Okay. Now, okay. Then results on conjugate and modulus. Okay. So some more discussion on conjugate and modulus. Okay. Conjugate. So in the previous session we have introduced what is called a complex number, and how do you represent a complex number. Like, say you have a real axis, you have a imaginary axis. So on x-axis you are taking the real, on y-axis you are taking the imaginary, and I is equal to square root of -1, and I to the power 4 is equal to 1, and those things. And what is Gaussian plane, Argand plane, and how do you represent? Okay. Then we had discussed the algebra of complex number. How do you do the addition, like say z1 plus z2, z1 minus z2, z1 into z2, z1 by z2. So those things, this multiplication, we don't have much time to remember, derive all those things. You have to remember the multiplication z1, z2. If z1 is equal to x plus iy 1, x1 plus iy 1, and if z2 is equal to x2 plus iy2, how to find z1 plus z2, z1 minus z2, z1 into z2, and z1 by z2. You have to by heart those formulas. Okay. We are not going into the derivation of it. Okay. And then we have discussed like what is the conjugate and modulus of a complex number. So if z is equal to x plus iy, its conjugate is equal to x minus iy. Okay. And the modulus of a complex number, z bar, is equal to the square of the real components plus square of the imaginary component, total summation of square of the real component plus imaginary component, then square root of that. Okay. So your x is equal to the real component, your y is equal to the imaginary component. So your modulus is nothing but z bar is x square plus y square. So that is your modulus. Okay. Similarly, you have z bar, that is called the conjugate. So that is nothing but x minus iy. Okay. If z is equal to x plus iy, is this. Okay, so this we have covered. Now then the results on conjugate and modulus of complex number. So some more details. Okay. So z is equal to x plus iy. Then yeah. So z is equal to x plus yy, z bar is equal to x minus iy. So z plus z bar is equal to the
2 times
2
the
into real component of z. Z minus z bar is equal to 2 into imaginary component. So this is, you can say, imaginary component of z. Okay. So when z is equal to z bar, that means your imaginary component are 0. So it is purely real number.
Yeah.
Okay. So when the conjugate is same with the complex number, its conjugate is same means those two numbers are purely real, right? That is one. And when z plus z bar is equal to 0, that means when it is equal to 0, it is purely imaginary. Okay, it's purely imaginary, right?
Yeah.
So that is another interpretation, because what it is, x plus iy plus x minus iy. Okay, so that means
No.
yeah.
Yeah.
So this will be like this will be
Minus of mine.
z bar. Yeah. So that means this part has to be, this x part has to be 0. Okay. Then only if this is 0, then only this will become equal to 0. So for when z plus z bar is equal to 0, then it's a purely imaginary number. That means the z will be equal to iy and z bar is equal to minus iy. So if that is the case, this is a imaginary number, this is a imaginary number.
Yeah.
Then only the addition of the complex number and its conjugate will be 0. Only both are imaginary numbers. Okay. Okay. Another thing is like Z1, Z2, its modulus. Its modulus is equal to Z1 modulus into Z2 modulus. That is one more derivation that we should remember. You can take a picture of this. That one. You can take a picture of this, then we will move on. So Z1 into Z1, Z2 whole thing modulus is equal to Z1, Z2 conjugate is equal to Z1 conjugate into Z2 conjugate. Okay, so Z1, Z2 conjugate is equal to Z1 conjugate into Z2 conjugate. So these are all interpretations. Okay, we are not deriving, but you have to remember those things. So, and again another thing is Z1 by Z2 whole conjugate is equal to Z1 conjugate divided by Z2 conjugate, provided Z2 conjugate is not equal to 0. Because if it is 0, is not equal to 0. If it is 0, it will become infinite. Okay, and then. And if conjugate, if what you can say, modulus of z, if modulus of z is equal to 0, that implies modulus of z is equal to 0 implies z is equal to 0. Okay, so see, modulus of z is equal to 0 means what? So x plus iy. Okay, so z is equal to x plus iy. So modulus of z is equal to x square plus y square square root. Okay, so if this is 0, that means because this is square, this is square. If this is 0, that means x is 0, y is 0.
Also 0.
Okay, if x and y both are 0, that means z is equal to 0. Okay, so. And again, there are some more. So Z1, Z2 modulus is equal to Z1 modulus into Z2 modulus. So these are some of the properties. We are not going into the derivation of it, but just remember all these things. Okay. And And another thing is z to the power n modulus. Okay, z to the power n modulus. Zn modulus is equal to z modulus to the power n. This is another important point regarding complex number. Okay, so z to the power n modulus is equal to z modulus to the power n. Okay, in this case n is a natural number. Okay, it's natural number. Okay, so this is one more inference. Okay. What is written here? Z to the power z bar by, what is written there? Z bar by?
That's good.
Okay. So one more thing is z to the reciprocal of z. Okay. So a reciprocal of z is nothing but z to the power minus 1, which is 1 by z, which is
1 by z to
so
z
it is
bar
z bar and z conjugate of z
by modulus
divided
of
by
z
modulus of z whole square. Okay. So this is your reciprocal of z. Okay.
Yeah.
Okay. So then, so these are some of the things, some of the properties of complex number. You should always remember. You take a picture, so you can go through it. Okay. So then we will discuss about the argument or amplitude of a complex number. Okay. Okay. So now we get into see, all these things are proven and derived. We are not deriving those things because yours will be MCQ questions. So these things you just remember. Then amplitude of a complex number, argument, or which is otherwise called as amplitude. Okay, argument or amplitude of a complex number. Complex number. Okay. Okay, so let us say this is my, I have already discussed it. So this is my imaginary axis. This is, let us say, my real axis. Okay, so this is my real axis. Real axis. This is my imaginary axis.
Okay.
Imaginary axis. Okay, so this is my real axis. This is my imaginary axis. So this is this, so this is x, and this is y. Okay, the imaginary component. Then if this is so, this angle that it makes, so this is the point P. Okay, so this is point P.
Yeah.
So this point P has coordinates x and y. Okay, this is point P and coordinate x. So the angle theta which OP makes with the positive direction. So this is my O. So the angle theta which OP makes with the positive direction of real axis. So this is my positive direction. So angle theta that OP makes with the positive direction of the real axis is called the argument or amplitude of z. So this theta, okay, this theta is called argument of or amplitude of z. Amplitude of z.
Okay.
The imaginary number. So this theta, okay. So what is this theta? This theta is nothing but, like you know, tan theta is equal to y by x in this case, right?
Yeah.
So theta is equal to tan inverse
y by
y by x.
Okay.
So
Understood.
this is tan inverse
Y by x.
y by x. So this is the argument, okay. Then the value of argument theta which satisfy the inequality that theta is in between minus pi to plus minus pi to plus pi is called principal value of argument, okay. So we'll discuss that, okay. So the argument value of z is not unique, it is theta or 2 pi plus theta, okay. So this is theta or it can be 2 pi plus theta, okay. So just remember at this stage the angle that the angle
Value is tan inverse y by x.
the angle which OP makes with the positive real axis is called the argument, and its value is value of argument is nothing but tan inverse y by x. So there are some interpretations related to argument also that you can go through. Like say, if z, z1, z2 are a complex number, okay. So one is argument of z bar is minus argument of z. Okay. So argument of z bar is equal to minus argument of z. Okay, so how is it? Because z bar is nothing but your x minus iy, right? Right. So your in this case your tan theta will be minus y by x, right?
Yeah.
Okay, and here this is the LHS. Okay, so this argument of z bar. So this is minus y by x. This is your LHS.
Yeah.
So here RHS will be minus argument of z, which is y by x. So this is RHS. So argument of z bar is equal to minus argument of z. Okay. And again some more interpretations. So argument of z1 z2 is equal to argument of z1 into argument of z2. Sorry, not into plus. Okay, that you have to remember. These are the things you have to remember. Argument z1 z2 is equal to argument z1 plus argument z2. And then argument z1 by z2 is equal to argument z1. So multiplication is addition, like logarithm. Argument z1 minus argument z2. So this is another interpretation. Okay. If z is purely imaginary, then argument of z is plus or minus pi by 2. So if it is z is purely imaginary, that means it is
no x.
No x. So the angle it will make with the positive x-axis is pi by 2 only.
Understood.
So
because there is no x real part.
so when z is purely imaginary,
Theta will be 90.
Imaginary, your argument of z is equal to plus or minus pi by 2.
Yeah.
Okay. And if it is purely real, your argument will be 0. Because it will be nothing but this axis. So the angle that it makes with the x-axis is 0. Okay. So
argument is nothing but magnitude of the.
Yeah, argument is nothing but the angle.
Yeah.
The angle. So if it is imaginary, angle will be pi by 2. If it is fully real, then angle will be 0. The angle that it makes with the so OP, that point.
Yeah.
So you have a point.
To define that point, that angle
See,
it makes.
suppose it is a real, it is fully real. That means that point will be on the x-axis.
Theta
So
will be
the
zero.
angle this OP makes with the x-axis will be 0.
Yeah.
If it is purely imaginary, OP will be like this. So the point will rotate by 90 degrees. So if it is a purely imaginary number, then your argument will be plus or minus pi by 2. So it is purely imaginary. Why plus or minus pi by 2? It can be like this, it can be like this also.
Understood.
So it can be positive y-axis, it can be negative y-axis. So these are some of the important interpretations, okay, related to argument, okay. Then there is something called you can take a picture, then we'll get into the other thing. So these important points you just remember because you don't have much time to derive all these things. But it's not anything difficult to derive. These are simple things.
Yeah.
Then there is something called square root of a complex number. Okay, square root of a complex number. So let us say z is equal to a plus ib. Okay.
Yeah.
If this is the thing, then z bar is equal to z square root. Z square root is equal to square root a plus ib. Okay.
Yeah.
So okay. So what it will be, you can write it as, okay, you can write it as plus or minus half 1 by root 2, 1 by root 2, then modulus, that is called modulus, right? Modulus.
Modulus.
Yeah, modulus of the magnitude. Okay, so modulus z plus a. Okay, modulus z plus a square root. Okay, so this is one modulus z plus a square root plus I modulus z minus a. Modulus z minus a z minus a z plus a modulus z plus a I into modulus z minus a. This, okay, then the whole thing inside a bracket.
Okay.
So okay, so how do we compare it? Plus or minus 1 by root 2. So modulus of z, okay, you know it is square root a square plus b square. Okay. So here it is modulus of z is square root a square plus b square, square root a square plus b square plus a square root, okay, plus I square plus b square square root, okay,
minus a.
minus a, okay. Okay, so if square root of z is equal to a plus I b square root is equal to 1 by root 2 z plus a square root z minus a square root. So this we can simplify it as like this, how we get it, okay. So you can write this as a square plus b square, okay, a square plus b square to the power half, right?
Yeah.
Then this one is also a square to the power half, right?
Yeah. Then whole to the
Then
power
whole
half.
thing to the power half, right?
Yes.
Half, okay. So
A power m plus a power n is equal to.
mm,
No, that we can't.
okay. Okay, so a plus b to the power m is a to the power m plus b to the power m, right?
Yeah. No, no. Here it is. If you take
No,
a
no, I am
square.
just putting a plus b to the power m. Okay, that is not a to the power m or b to the power m. No. So,
You can take a square plus b square as one term and a square as one term because both of them have the same powers.
okay.
A power m plus b power m.
Okay. Okay. So, okay, fine.
And then you can,
Okay,
whatever you
let
get,
us
it will
try.
become a power m into n.
So, a square, uh, so a square to the power m, that's what you are telling, half, right?
Yeah.
Then plus,
No, no. A square plus b square.
what do you want to do? So, a square plus b square to the power half. So it's not that simple. Okay. So a square plus b square to the power half. You so there can be that this can be based on that maybe that binomial theorem kind of stuff. You guys see a square plus b square to the power half plus a square to the power half. Okay. Then whole thing to the power half. Okay. So whether okay, and then plus I into a square plus b square to the power half, okay, minus a square to the power half, okay, then this whole thing to the power half, okay. So this it gets simplified to this, okay. Plus b square to the power half, and then a to the power half, okay. So then whole thing to the power half, a square plus b square to the power half minus a square to the power half, whole thing to the power half. Okay. So okay, I think we can do this detailed derivation. We can refer your NCERT book for the detailed derivation of it. Okay. Just at this stage, you just remember square root of a plus square root of a plus ib is equal to 1 by square root.
That much. Square root of z is equal to square root of a plus ib.
Square root of z is equal to square root of a plus ib.
ib and then that next one.
That anyway you are replacing by a plus ib. What is there? Just the next step is this actually. So how they got it? That is our intention. Okay, so see so it is like we have to do that 1 by root 2 z square root of z plus a. Okay, then this whole thing. Okay, this plus I into z minus a, then square root. Okay, so this is the formula. This we have to remember because we can find out z actually. So z is nothing but a square plus b square square root. So you any number you know a square plus b square square root, and that square root you can add with a there.
Yeah.
Okay, so that then this with actually this a yeah, so here it is nothing but your a is nothing but your a square into half. Okay, this is the thing, right?
Yeah.
So it become a square plus a square to the power half, okay, plus b square square root this side. Okay. So
that is also in square root.
which one?
A square plus b square is in square root.
I put it in square root only, na?
Only those two are in square root because that is z modulus.
Modulus z and a both are in square root.
A square plus b square root plus a whole square.
Okay, a square plus b square square root. Okay. Okay, so okay, fine. 1 by root 2. Okay. So it is nothing but a square plus b square square root plus a square square root. Okay. Right? A square square root is nothing but your a, and then whole square root. Okay.
Yeah.
So that's similarly plus
a square is not in square root now.
A square root is a, na? That is
Okay, one part.
So a square plus b square square root plus a square root.
Yeah.
Okay. And then I into whole square root, then a square plus b square square root
minus
okay,
a
then
square square root.
minus a square
root.
Square root. Okay. So just what you when you are trying to find out the root, you have to find out z, the modulus of z, that is a square b square. So this formula just you have to remember.
Yeah, understood.
Okay. You have to just remember that formula.
Okay.
That how to find out the square root, modulus of z plus a, I into modulus of z minus a, like 1 by root 2 modulus of z plus a square root plus I into modulus of z minus a square root. Just you have to remember, we will do the derivation, okay, when we have more time. Okay, take a picture of it. that is about the square root of a complex number. Okay. Okay. Some more important things related to complex number. Okay. So so what is that is the concept of application of complex numbers in geometry. Okay. So if the distance between, so if Z1 is represented by a point P, okay, and Z2 is represented by a point B, the distance between A and B is nothing but your, and the distance is nothing but Z1 minus Z2, the modulus of Z1 minus Z2. So like Z1 is, let us say, x1 plus I y1, okay, Z2 is equal to x2 plus I y2. So your Z2 minus Z1 is equal to your x2 minus x1 plus I into y2 minus y1. So this is this. So the modulus of this
that is the distance.
Is nothing but the distance. Okay, so it is nothing but x2 minus x1 whole square plus y2 minus y1 whole square. Okay, so this is very clear.
From
so
distance,
suppose,
it's like distance.
yeah, suppose this is a point A and this is a point B. Okay, so this point is, it does not nothing but it represent x1 y1. This point represent x2 y2. So your this side is x2 minus x1 and this side is nothing but your y2 minus y1. So the distance is nothing but this distance. So this is nothing but y2 minus y1 whole square plus x2 minus x1 whole square. So if you know z1 and z2, then the distance between the 2 points, if 2 points are represented by z1 and z2, the distance between them is the modulus of z1 minus z2. That is one. And let E z divides the segment z1 and z2. So so this is again, so this is z1, this is your z2. So let a point P is your z. Okay. If this is the case, then and if it bisects it by a ratio m is to n. Okay. If this is m and this is n, then for internal division, so it can be internal division or it can be external division also. If it is external division, this is m and this is n, right?
Yeah.
If it is internal division, this is m and this is n. Then for the internal division, the coordinate of point that z will become, for internal division it will be m into z1, m into z2 plus n into z1 divided by m plus n. Okay, so that is for internal division. For external division, it will be m into z2 minus n into z1 by m minus n. That is for external division. Okay, so that is one more application of complex number in geometry. Okay, and how to find the area of a triangle if its vertices are represented by z1, z2, z3. So let us say this is z1, this is, let us say, z2, let us say this is z3. Okay, so if this is the case, how to find the, so if this is the case, the CG, let us say this is my CG. So this CG, the coordinate of the CG will be coordinate of CG will be 1 by 3 z1 plus z2 plus z3. So this is another application of complex number in geometry. And then how to find the area. So this is, let us say this is a ABC. This is my triangle. So area of this triangle ABC is equal to that. You can write it as
determinant of z1, z2, z3.
half z1, z2, z3. Then z1 half. Okay. And then Z1, yeah, that is the conjugate, Z1, Z2, Z3. So these are the conjugate.
And then 1, 1.
Then 1, 1, 1. 1, 1, 1. So
determinant.
So this is the determinant of this term. Okay. So this is my area of the triangle with vertices as Z1, Z2 and Z3. Okay, so this is third application of complex number in geometry. Okay, and for a equilateral triangle, means where all sides are equal with vertices Z1, Z2, Z3,
You can
ABC.
use that only.
Huh?
You can use that.
Yeah, you can use that. Okay, so Z1, so the interpretation is Z1 square plus Z2 square plus Z3 square. Okay, so for a equilateral triangle ABC with vertices Z1, Z2, Z3, Z1 square plus Z2 square plus Z3 square is equal to Z1, Z3, Z2, Z1 and Z1, Z2. Okay, that is for a equilateral triangle. Okay, so these are some of the interpretations. Okay, and then there is something called concept of rotation. Okay, so yeah, you can take a picture. Okay, so these are all applications of complex number in geometry and applications of complex number in geometry and then so let us say this is my triangle, this is A, this is B, this is C, this is Z1, this is Z2, this is Z3, and then this is my angle alpha. Okay, so if this is my angle alpha, then alpha is equal to argument Z2 minus Z1 divided by Z3 by Z. So argument Z2 by Z1, Z3 by Z1. Okay, so this is the angle. So this Z2 by Z1 by division formula you have to find out. Okay, and first you have to find out Z2 by Z1 by subtraction formula. Then this Z2 by Z1 and Z3 by Z1 by division formula you have to find out. Then after that, whatever number you get, argument of that is this angle. Okay, so here this that concept of division you have to apply. Okay, so this is how to find the angle knowing the three vertices
of a triangle.
and vertices of a triangle. Okay, and square root of a complex number I have explained already. Then cube root of unity. Okay, so one, you know, one will have one square root, one you know. Okay, so other like say other two roots of like say cube root of unity. Cube root of unity means there will be three roots. Okay, cube roots means it will have three roots.
Yeah.
So one root is omega 1, other is omega, another is omega square. So these are the three roots of unity. So first root, this omega is equal to, just you have to remember this, is equal to minus 1 plus root 3i divided by 2.
Omega square
Omega
is
square
minus 1
is equal to
minus 1 minus root 3 by 2.
minus 1 minus root 3i by
2. Yeah, this I remember.
So these two things you have to remember. Okay. And then properties of cube roots of unity is like 1 plus omega square is equal to 0. This is one property. Okay. And then omega square is equal to 1. Omega square is equal to 1. That is another property. Okay. Then 1 plus omega n plus omega to the power 2n is equal to 0 or 3. So 1 plus omega n plus omega to the power 2n, omega n plus omega to the power 2n is equal to 0 or 3. Okay. So it will be 0 if n is not equal to 3m, it will be 3 if n is equal to 3m. Okay. So there are some conditions associated with it. If n is not equal to 3n, if n is equal to 3n.
3n.
So these are some properties of cube root, okay, of unity, okay. And then there is something called Muybridge theorem. Okay, so this is also an important one, and during our time also I remember we have studied this. Okay, this is an important theorem that also you have to remember. That is the Muybridge theorem.
Terms of cos
So what does it say? Cos theta
plus I sin
theta to the power n is equal to cos n theta plus I sin n theta. Cos n theta plus I sin n theta. Okay.
Integral multiples of n it has to be 2.
Yeah.
As integral multiples of the power to which it is raised.
Yeah, cos n theta plus I sin n theta. So this is your Muybridge theorem.
Yeah.
So now with this we have almost covered everything. If you remember all these things, anything that comes related to complex number, you should be able to solve. Okay. Okay, that's all. So we are done with complex number. Now you have it's your time to practice. Okay.